Good morning, everyone. My name is Vito DeGidio, and I will be discussing the safe handling of compressed gas cylinders set out by the Occupational Safety and Health Administration for the 25M SATC220 course, and that is with Dr. Milton Saidu as the professor. Sequence of events for today's training: we will conduct a needs assessment and discuss who and why they need this training. We'll go over learning objectives, go over some prerequisites, dive into the 29 CFR 1926.350 alpha. We'll go over a few of the commonly encountered hazards when dealing with compressed gas cylinders. We'll then go into the actual OSHA standards themselves and go into the best practices for handling compressed gas cylinders. And then we'll do a 3-question knowledge check that's going to identify if we learned about what we were trying to achieve today. So the needs assessment. Who needs this training? All personnel working directly with or in the vicinity of compressed gas cylinders at job locations or on company grounds. And why attend this training? So we can identify the risks associated with compressed gas cylinders. We can review and learn from prior company safety compliance issues with compressed gas cylinders and ensure we are adhering to what occupational health and safety states in their regulations. So the learning objectives, we're going to identify key hazards associated with the transportation, movement, and storage of compressed gas cylinders. We're going to describe OSHA's requirements set forth in 29 CFR 1926.350 alpha. We're going to demonstrate and review proper transportation, movement, and storage techniques utilizing real-world examples, case study reviews, and visual aids. Prerequisites, you have to have the ability to recognize basic safety hazards on the job site, and that is something you should have definitely coming into this training. Knowledge of violation reporting procedures, knowing who to talk to, such as a safety manager, supervisor, safety technicians. So that can be, so if one of these violations does take place, we know how to correct it in the future. And you don't have to have any prior knowledge involving compressed gas cylinders. So the main publication we're looking at today, the main standard, is going to be 29 CFR 1926.350 alpha, which is under gas welding and cutting. And then if you go a little further into part A, you're going to look at transporting, moving, and storing compressed gas cylinders. So it's going to dive into those 3 topics and discuss each one of those. We're going to discuss each one of those individually, transporting, moving, and storing, and see what OSHA has to say about how to properly do those and the common things you might see. So the first hazard you might see is an explosion, and in this video you can see how violently and how quickly it happens from a gas leakage.
People who pick post-university choose our MS in Counseling and Human Services because they want flexible classes that are on their schedule and on their budget, so they can help themselves while they help others. Are you a post person?
Another common hazard is a missile hazard. So in this hazard, this can happen when a regulator is knocked off, or say the gas cylinder is tipped over and it hit without a proper valve cap, and it hits some type of ledge that knocks that regulator off. And if someone were to be in front of this, I think very serious injuries could occur. Another common exposure hazard you might experience is toxic gas exposure, asphyxiation. So toxic gases are going to be carbon monoxide, hydrogen sulfide, nitrogen oxide, or ozone. There's obviously more common. There's all these obviously other toxic gases, but there's potentially varying lethal effects that these can cause. And the main way to prevent any of these lethal effects from affecting you is to ensure you're working in a well-ventilated area with proper working HVAC equipment. Don't stay in the confined area for too long of a period. Use proper PPE, and that can prevent toxic gas exposure from happening. So an asphyxiant is a little different, but it's also along the same lines. So it's minimally or entirely non-toxic, but can dilute the amount of oxygen in the air. So basically what happens is the gas overtakes the oxygen, and oxygen is essential for life. And when you can't breathe, these effects will start to unrecognizably affect you. So some of the things, as you can see in the thing on the right, in the picture on the right, is some of the effects you might feel, but at the same time, it can happen so quickly and be completely unrecognizable until you pass out. And that point, if nobody's around you, if you're working alone, you could possibly succumb to the issues. So examples of asphyxiants are argon, carbon dioxide, carbon monoxide, helium, methane, nitrogen, and propane. Another common hazard is a crush injury. This can happen with your hands, your feet, your extremities, a variety of things. And it typically would happen when two cylinders get crushed together. A cylinder hits a wall, a cylinder falls over and crushes your foot. And that is why it's essential to always wear proper PPE when handling compressed gas cylinder, just due strictly to the size, their weight, and the damage they can do. So ANSI Z41 has proper PPE protection, especially for foot protection, and you can also get with your safety manager to discuss any requirements for foot protection. Another example is fire. So fires can happen extremely quickly when there's a source of ignition around these toxic gases and compressed gas cylinders. One catches fire, and as you can see in the video, it does not take long for the others to go up in flames. They just completely compound each other, and it gets quick, just happens so fast. So now we're going to go directly into the OSHA standards in 1926.350, and we're going to discuss what it says about transportation. So in parts 2, 4, 5, and 6, when transporting, these are also in my own words. So if you want to refer to the actual OSHA regulation, that's where you can find what it says. But just to make it easier for everyone, you want to hoist cylinders with cradle, sling boards, or pallets, not using magnets or choker slings. The main reason for that is because the ability for them to fall out of those slings or off of the magnet is a lot higher than if they're secured when being transported. Secure cylinders upright when using powered vehicles for transport. You don't want to lift cylinders by valve caps, and thaw frozen cylinders with warm, not boiling water. Those two are connected into the same thing, so we don't want to go too far, but that just don't lift the cylinders by valve caps. You want to remove regulators and install caps before transporting unless secured by a special carrier. So you want to remove the regulators and install the caps so the location where that compressed gas can escape is secured. So movement found in 3, 8, and 9. You want to move cylinders by tilting and rolling. You never want to drop them or allow rough contact. Obviously, you don't want to drop a cylinder due to multiple different reasons, but you want to just make sure when you're moving them that they are being moved properly. You want to close valves when the work is done. Cylinders are empty or in transit. Keep cylinders upright at all times except when being hoisted or carried briefly. And then lastly, storage. Ensure valve protection caps are installed and secured during storage. Use cylinder hand trucks, chains, or devices to prevent tip over. During storage, you want to separate oxygen cylinders from fuel gas or combustibles, especially oily or greasy, by a minimum of 20 feet in distance, or a non-combustible barrier 5 foot high with a half-hour fire rating. And if you're looking for information for plants, You can find that in the Compressed Gas Association pamphlet P, TAC 1, TAC 165. So for best practices, now that's what we're going to go transition into, using hand truck. Obviously, as you can see on the right, those two compressed gas cylinders are secured. They're being utilized and moved on a hand truck that has a wheel reinforcement. So if it were to slip, they wouldn't just fall. That second set of wheels would catch them. And they are secure there. They're not going to be moving around while the movement takes place. Securing cylinders, you want to secure cylinders upright and utilize a mechanism to prevent cylinders from tipping over, such as the brackets you can see on the right. If, for example, a good example I've seen is utilizing brackets like that is going to help if some inadvertent event takes place, such as like a forklift backs into that. If on the left there, if that bracket's not down, those two compressed gas cylinders have the potential to tip over, whereas on the right, that chance is a lot lower for them to tip over. So for storage, you want to always store them upright in a good, well ventilated and illuminated area, just so they can be monitored, and make sure that the proper distance is maintained from other materials or combustibles. Valve caps, you always want to keep valve caps in place when not actively using the compressed gas. So if you're not using it, put a valve cap on. It can help prevent a lot of unnecessary mistakes. And then during transport, obviously, ensure the regulator is removed and valve cap is in place. So now we're going to go into our 3-question knowledge check, and we're just going to discuss a few of the things we discovered today that are important things to remember and see how we did. So let's get into it. Knowledge check question number 1. Which of the following is an approved method of hoisting a compressed gas cylinder? Using a choker sling, hoisting it by the valve cap protection cap, via cradle or sling board, or with a magnet attached to the cylinder? Correct answer is C, and that is stated in 29 CFR 1926.35 alpha 2. Next question. How should oxygen cylinders be stored in relation to fuel gas or combustible materials? At least 10 feet apart or separated by a non-combustible barrier at least 10 feet high with a 1-hour fire rating. Side by side with no protective barrier. At least 20 feet apart or separated by a non-combustible barrier at least 5 feet high with a 30-minute fire rating. Or in a sealed container to prevent leakage. Correct answer is C, stated in 29 CFR 1926.350 alpha 10. It's going to be at least 20 feet apart or separated by a non-combustible barrier at least 5 feet high with a 30-minute fire rating. Last question. Question number 3. Before moving a compressed gas cylinder, which of the following actions must be taken? You want to roll the cylinder from the top, remove the regulator and secure the valve cap, place the cylinder horizontally for easy movement, or bleed the valve to relieve the pressure. Correct answer is B, remove the regulator and secure the valve cap. That is stated in 29 CFR 1926.350 alpha 6. So closing remarks, if you have any questions, please get with me or the safety manager in your department. So safety of compressed gas cylinders is obviously going to be extremely important. We saw some of the severe hazards that were encountered, and we want to maintain and make sure that the company adheres to those standards. So if there's anything that you think could potentially be hazardous and a violation of OSHA, we want to make sure we handle it internally and get it corrected as soon as possible. And if you have any other if you need any other information or want to review some of the sources that were utilized in this presentation, you can look up 29 CFR 1926.350 alpha. You can look into the Air Gas ebook series, pamphlets 1, 2, and 3, which discusses all things compressed gas cylinders. Or you can also look into the Compressed Gas Association pamphlet P, TAC 1, TAC 165. Thank you for attending your training, and always stay safe.